Hi guys, welcome back. Today we will solve one of the LeetCode problem, that is finding the maximum product of two elements in an array. So you have been given an array, and array can consist of say two or more elements, assume, and it has both positive numbers and negative numbers, and you have to find maximum product of any two numbers. So you have to find two elements such that their product is maximum. In this given example, the maximum possible output is 6 5s are 30. So 30 will be the maximum possible product, right? So we have to print that 30. Okay, let's see how to solve this. So there are several ways to solve this problem. I see at least 3 approaches are there. So we will explore and discuss each of those approaches. Okay, and let me first write the first approach, which is pretty simple. Here we will just run two loops from I equals to 0 to length and j equals to I plus 1 to length. This way we will find all two combinations of the array and we will find that product, and we will print the maximum product. So j should run from I plus 1, and again j less than array length j plus plus. If this is greater than max product, we have to store this into max product. Okay, if indexes also required, let's store the indexes as well. Latest max at index equals to I, and the second element index is at j, right? And finally just print that. Let's try to run and see the output of this. Okay, so the max product is 30 and found at index 3 and 6, right? So this is 3 and this is 6, which is correct. So let's write the second approach. So in this approach I will use the sorting algorithm. So by the way, the complexity of this algorithm is, because we are having two loops running from 0 to n, so the complexity will be big O of n square. Okay, let's try to run the second approach, which uses the sorting. Okay, so we have inbuilt sorting mechanism, so which will sort. And once we sort all the negative numbers, so the sorting will be in ascending order, so all the negative numbers will be at the left hand side and all the positive numbers will be at the right hand side. So two extreme right elements and two extreme left elements I am comparing. Okay, so whichever is max, that will be our output. And here the problem is, inbuilt sorting mechanism is, we will lose the indexes. Okay, our main intention is to solve the problem in different ways. Okay, right? So we have to print this one. Yeah, let's see. Let's try to run and print the output. Sorry for this. Yeah, so max product still we got 30. That is good. Now let's try the third approach, which is the optimal approach. By the way, what is the sorting algorithm complexity? N log n, right? So this approach to the complexity has n log n time complexity. Let's try to solve it. The most optimal possible solution is linear solution. Okay, let's try that one. So in the linear solution, what I will do, I will just run one loop starting from 0 to length, and then every time I will have 4 variables here. Okay, so I call it as a positive A, positive B to store both biggest positive numbers, also negative A, negative B to store the smallest two negative numbers. Okay, so now as I said, like, I will take one loop which will run from 0 to length. Here what I will do is, at every element I will compare. If the current element is greater than positive a. So positive a will be having the largest positive integer. So positive b will be having the second largest positive integer. Similarly, negative a will have the largest negative integer, and negative b will be the second largest negative integer. Okay. So if the current element is greater than, or let me do this, if the current element is greater than positive a, so what we have to do? Then we have to do, first we have to put positive a into positive b, because this largest positive element so far will become the second largest positive number, right? So that's why I have assigned positive a to positive b, and then in positive a number we have to put array of I. Okay, simple. If the current element is greater than second largest positive number, okay, then what we have to do? So it's not greater than first positive number, but greater than second positive number. So we have to update just the second positive number. Okay, that's it. So let's do the same for negative numbers as well. If array of I less than negative a, largest negative integer, we have to do same as what we have done for positive numbers. Okay, and then negative a will get updated with newest element. Okay, that is the current element. Else if array of I less than negative b, so the current element is not less than the largest negative integer, but less than second largest integer, then we have to update only the second largest integer. Okay, negative integer. Great. So with this we got, by end of this loop we will get two biggest positive numbers and two biggest are negative numbers. Okay, yeah, just print those numbers like this. Here we have indexes, we can store the indexes as well, but for time being I am not storing any integers, so just let's print the max product. By the way, we have to do one more comparison. Now we have got the largest two positive integers and the largest two negative integers. Okay, we have to compare basically. So product of those positive numbers and negative number we have to compare and see which one is greater. Negative a star negative b. Okay, if so, then we have to say, if not, we have to print negative numbers. Okay, great. So let's try to run this and see the output. Okay, just let's try to run and see. Yeah, see, we still got the max product as 30. Okay, let me change this to 5. Okay, now we should get 35 is the answer. Okay, it should be now 35. Let's try to run and see all three approaches. Everything should return 35. Yes, and at index 1 4. So 1 is this and 4 is this. Yeah, working good. So that's it. So we have three approaches. In first approach we used two loops and we figured out all the combinations of two numbers from the integer array, and we will try to see their product, and every time if the current product is greater than max product, we are just storing replacing the current max product with the new max product. Okay, so that is the first approach. The complexity is n big O of n square. So this approach, first approach, complexity is big O of n square. Okay, and in the second approach we did just sorting. So sorting, we know the least possible optimal solution or complexity we have is n log n. So and then least leftmost two elements we compared with the rightmost two elements, because after sorting the leftmost will have the biggest negative integers towards left and biggest positive integers towards right. So we just took the product of those. So here the assumption is the array has at least 4 elements. Okay, so we have to write the base conditions, like if array has less than 2 elements or less than 4 elements. So those two base conditions we have to write here. That can be taken care, not a big deal. Okay, so and then we have taken product of the first 2 indexes and the last 2 indexes, and we will see we printed the max product accordingly. And in the final approach, which is the linear approach, so I have traversed the array only once, and every time I have maintained 2 positive integers. This is the largest positive integer and this is the second largest positive integer. Also 2 negative integers. So this is the largest negative integer and this is the second largest negative integer. So every time I am updating as and when one of these conditions are satisfied. Finally, I took the product and printed the max product. I hope, yeah, let's do the complexity of these two. So as I said, like this is using the sorting algorithm, so the complexity will be n log n, and the last one is linear search, so the complexity is just n. So this is the best possible solution to this problem. I hope things are clear. If you still have any doubts, please leave a comment. I will try to answer you guys. Okay, thank you guys, bye bye.